Welcome to the YouTube channel Command Line. This is the second video in the CLRS series. So in this video, we are going to learn insertion chart. We took insertion chart because it is one of a simple algorithm. So here we are just going to sort and the procedure to sorting is also simple. Then the algorithm is not very hard to understand. That's why we have taken this algorithm. The motivation here is thinking of a problem from the programmatical aspect. Programmatical aspect in the sense, we cannot simply go to a computer and say, just solve the problem. So you have to tell the computer in step-by-step manner because systems has only primitive amount of steps. For example, you can just assign a number to another variable, or you can add two numbers, or you can compare two numbers and based on that make an action, or you can go in a loop until some condition satisfies. So these are the very basic primitive steps a machine can do. So the machine is capable of only these kind of simple primitive steps. So when you tell a machine to sort something, it doesn't know what to do that. So what we have to do is we have to convert the problem into the primitive steps and tell the machine in the primitive steps which machine will understand. So in this video, we have taken the problem of sorting and then we will convert that into primitive steps. Primitive step means the basic steps which machine can understand. And then we will tell the machine in such a way the machine will work out the problem. So this is the way of writing a code. Like you take a problem and then you tell to a machine in the way the machine can understand. Okay. So you must be able to kind of correlate now. So we are going to talk with the machine. Okay. So we are going to communicate with the machine. So what is the medium for communication? Language. So that is the reason we are calling these programming languages as a language. So this is the way we are going to communicate with the machine. First, let's see what is sorting. Most of you may be knowing what is sorting already, but let me just give a simple introduction about what is sorting. So as we told in the previous video, an algorithm is something which will take an input or a set of inputs. So here for the insertion sort algorithm, the set of input is a set of numbers. Okay, it is going to take n number of values, n number of integers. It is going to take n number of integers. Let's call the integers as a1, a2, a3 until an. Okay, and this is in a random order. So this is the input we got. And we expect the system to reorder the given input sequence into another sequence. So the output sequence is not something new. It is reordering. It is a permutation of the input sequence in such a way the numbers are in sorted order. It means we got a new sequence as a1 dash, a2 dash, a3 dash, a4 dash until an dash in such a way a1 dash is less than or equal to a2 dash and a2 dash is less than or equal to a3 dash. Until it happens till we reach an. So this is what we expect from a sorting algorithm. Okay, so we didn't get into insertion sort. So any sorting algorithm, we expect the sorting algorithm to do this. For example, when you have the input number sequence as 5, 2, 4, 6, 1, 3, I want the sorting algorithm to reorder this into 1, 2, 3, 4, 5, 6. So you can see the a1 dash, a2 dash, a3 dash is like 1, 2, 3 such a way it reaches 6. And you can see the sorted order is 1 is always less than or equal to 2 and that is 2 is less than or equal to 3 and 3 is less than or equal to 4 until it reaches the end of the sequence. So now before going into the pseudocode, before going into the algorithm actually, let's think why we need sorting. Okay. We got a set of input number and then we sort again it is sequence of number and in such a way it is sorted. But how is it matters? Why we require a sorting algorithm in first place? Why we need to sort some integer numbers? So we don't usually want to sort the numbers. Okay, these numbers are keys and those are associated with something else, and we want to sort the something else based on the keys. For example, you take a class of students and we want to put them in ranking order based on their mark. So there the mark is their key and whom we are sorting, we are not sorting the marks, we are sorting the students. So we call the students, the associated data is satellite data here. So the example is we rank students based on their marks, the marks is the key here. And another example we can say we want to create a telephone directory. There we are going to sort the names based on the letters arranged in the word. We are going to sort the names alphabetically. Another example is you are going to plan a parade. There we want to keep people in the order of their height. So here height is the key. Based on the height, you are going to arrange the people, and you are going to arrange people based on their height. You are not just going to arrange the heights. So here we do sorting. So usually we do sorting on a key to arrange the satellite data associated with the keys. Let's get into insertion sort. So there are many sorting algorithms. Something is better, something is worse. We are going to see that in some time. So in this video, we will just see insertion sort. So here, don't worry about sorting, how efficient it is, or can we do something else, quick sort or merge sort. You just try to understand what is insertion sort. And the more important point here is, how are you converting the insertion sort into a programmatical aspect, into a program, so that you should be able to tell a machine to do insertion sort. Okay, this is more important here. This is called as insertion sort because we are going to take one number at a time and then we are going to insert into some place. Let's say we have two sides, right side and left side. Initially, the right side is having all the numbers and the left side is empty. Okay, now I am going to take one number at a time from the right side and I am going to insert that into the left side. So first I am taking the number 5. So left side there is nothing. I just directly insert here. So just assume that left side has enough space to hold all the 6 numbers. So when I get the 5, I just put it to the first open space I have in the left side. Next, I have taken 5 from the right side. So it means right side has remaining 5 numbers 2, 4, 6, 1, 3. This time I am going to take number 2 and then insert here. But while inserting here, I am not just going to insert in the next available space. I am going to start from the rightmost in the left side and then going to compare each and every number. So the right side now is having number 5. So now I compare 2 with 5. 2 is less than 5, so that I'm going to shift 5 into the right, like next slot, then 2 goes in front of 5. So the left side becomes 2 and 5. On the third iteration, I'm picking number 4. This time when I compare number with the rightmost element in the left side, which is number 5, so 4 is less than 5. So next when I compare that with 2, actually 4 is greater than 5. Sorry, 4 is greater than 2. In that case, 4 should be squeezed in between 2 and 5. So left side becomes 2, 4, 5. On the next iteration, taking number 6, comparing that with the rightmost element, which is number 5. So number 6 is already greater than that. So 6 goes next to 5. So the sequence becomes 2, 4, 5, 6. Then next sequence I am taking number 1. So this time when you compare that with the rightmost element in the left side, which is number 6, 1 is less than 6. Compare the next element, 1 is less than 5. Compare with next element, 1 is less than 4. Compare with next element, 1 is less than 2. So 1 should be inserted all the way in the front in the left side sequence. So the left side sequence, all the numbers will be shifted one position right, and number 1 will be inserted in the leftmost slot. So sequence becomes 1, 2, 4, 5, 6. Now in the last iteration, I am going to take the number 3. Compare that with 6. 3 is lesser than, compare that with 5, 3 is lesser than, compare that with 4, 3 is lesser than, compare that with 2, 3 is greater than. So shift everything from 4 to one slot right and then insert in the empty slot, 3 in the empty slot. So sequence becomes 1, 2, 3, 4, 5, 6. Now you might have got the understanding why we call this as insertion sort. So we have a set of empty slots and then we take the numbers one at a time. We take the integer one at a time and we are inserting that in the right position on the left side. Okay, we are not just inserting, we find the right position, we create a space for that number and then we insert the number on the left side. We take one number at a time and then we insert, that's why it is called insertion sort. So one thing you have to notice here is the left side column is always sorted. If you see the slide once again, in every iteration, the left column is always sorted. First time it is 5, second time it is 2 and 5, third time 2, 4, 5, fourth time 2, 4, 5, 6. So every iteration you can see the number in the such a way that a1 dash is less than or equal to a2 dash and a2 dash is less than or equal to a3 dash until it reaches an dash. So the sequence on the left side is always in a sorted order. So when all the numbers on the right side get exhausted, the left side has all the numbers in sorted order. Okay, can we think where we do insertion sort in practical life, like when you're playing a game or something. Have you ever done insertion sort? Like you keep two pile of things and you take one item from the one pile and then insert in the other pile in the right order. Can you think of it for a moment? Yeah, one nice example is playing cards. So you think like the card is thrown in front of you, you have a pile of 6 cards. You are going to take one card at a time and then insert that card on your left hand side. Maybe I can take a set of playing cards and show that to you. Just give me a moment. Okay, let me continue like this. So I have a deck of cards. I have 6 cards like the one we have that in the example we have seen. So let me place that on the deck here. So consider this is our right side, right side. So from here I'm going to take one card at a time and then insert in the left hand side. So here it is empty. So consider I have 6 slots. I'm going to take one card at a time and insert here. So the first time there is nothing. I don't need to compare anything. So I just inserted the card here. So second card when I take, I do the comparison. 2 is less than that. So I put it in front of 5. So third card I am taking, I am comparing with 5. It is less than 4 is less than 5. Comparing with 2, but 4 is greater than. So I am going to put it inside. So 5 is shifted right and then inserting 4 here. Okay. Similarly, taking the fourth card. So the fourth card is number 6. I am going to compare that with the last card, rightmost card in the left pile. Comparing that, okay, so this is 5. 6 is already greater than that. I am inserting it here. So taking the next card, which is nothing but 1. So comparing that with 6, smaller, 5, smaller, 4, smaller, 2, smaller. So I'm shifting everything on my left hand side to the right. So I'm inserting 1 in the leftmost side in the pile. So everything is shifted towards right. Now taking the last card in the pile on the right side, comparing that with 6 less than, 5 less than that, 3 is less than 4, it is greater than 2. So I'm going to shift 4, 5, 6 onto my right and then inserting 3 in between 2 and 4. Okay, so this is the insertion sort. We took one card at a time from the pile and then we inserted that in its right position on the left hand side. So that's why this is called insertion sort. Now let's implement the insertion sort in code. Here we have Python implementation. Python is relatively simple language other than other languages comparatively because this is kind of more related to English. So the if comparison, the loops are kind of more intuitive other than having more symbols like JavaScript or C, any languages having like that. So that I choose Python. But this course is not language specific. So you can implement that, you can practice it in any language you have. So you try to implement in any language which you are comfortable with. Suppose you have a problem in that, please mention that in the comment with your full code. I will try to answer. I will try to pinpoint where actually you are missing. Okay. Now let's go into the code. So I have implemented insertion sort as a procedure, as a function, I mean to say. Okay. So this is a function name which is insertion sort and it takes input a list and then it is going to output one list. Okay. So as we have seen, insertion sort is going to take the sequence of input which is a sequence of numbers and then it is going to output the reordering sequence of the same set of numbers. Okay. Now on the line number 2, first thing what I am doing is I am going to initialize empty spaces. So I got a list of integers. I am taking how many number of integers are there in the input sequence. So so Python has a construct called len and the len will tell you how many integers are there in the list. So I am creating an empty list named left hand and all the numbers in the that left hand are going to be initialized with 0. So how many spaces are going to be there in the left hand list is same as the number of elements in the input sequence A. Okay. So then I'm going to take, so now we have 2 places. The one is the left hand, the other one is the right side is the A. So consider A, the list A is the right side and left hand is the left side list. Okay. Now we are going to take one element at a time from A and then we are going to insert that on the left side in a sorted order, in a sequence order. Okay. So we take one element at a time. For that Python has this for loop. So this I will be the index in the list A. So I will be from 0 to len minus 1. So if there are 6 elements in list A, so I will traverse from 0, 1, 2, 3, 4, 5. So len will be 6 and I will go to 6 minus 5, 5. Okay. So on the first iteration, right hand. So right hand means you think like we are playing a card. The left hand is the one where I am going to store all the cards, and right hand is going to keep one card at a time. Whichever card I am taking from the pile is going to be there in my right hand. So that I have a variable called right hand. So the first card I am going to take is the first element, the top card in the list A. Okay. So I value is 0. So A of 0 is the first card. Right hand is having the first card. Okay. Now I'm going to compare that with my left hand side. My left hand is currently empty. First is I need to know how many cards are there in my left hand. Okay, how many cards I need to compare. So that I'm saying I'm using construct here. Like when I'm taking nth card from the right pile, it means I have n minus 1 cards on my left hand side, right? So when I take the first card, I have 0 card on my left. So when I take the third card, I have 2 cards in my left. That's why I'm going to assign how many card I have to compare with first. So first time I have 0 cards in my left. So it means I have to compare with no cards. That's why it is going to assign with minus 1. J will be minus 1. And this while loop will check. We will keep on going to the comparison on the left hand side. As long as either all the cards, the pile is completely, the card in my right, I'm taking one number at a time. And then comparing, I'm taking starting from the rightmost card. So we are keep on comparing the subsequent cards until the card in the hand is less than the card which we are comparing. When we see the card on the deck we are comparing is greater than that, we are stopping the comparison, right? So we have to do the comparison until the card on the right side, right hand is smaller. So the while loop is keep going until the right hand is less than the index in the left hand, whichever card we are comparing in the left hand. Also, we shouldn't keep comparing once we reach end of the deck on the left hand side. So left hand we have, let's say, 4 card. We cannot keep comparing on the minus 1, minus 2 card. So once we reach the end of the left hand, we have to insert the card on the leftmost side. So when we took the number 1, so we compared with all the numbers and then it went to the leftmost side. Okay. So the while loop will stop at 2 conditions. One condition is when the comparison reaches the end of the left side, sequence. Okay. The other side is when the card in the right hand. The other condition is when the card in the right hand is actually greater than the card which we are comparing in the card in the left hand side. Okay, there are 2 conditions. If when the 2 conditions are false, we have to keep doing the iteration. That's why the conditions, if you see, they are opposite of the condition which we have to stop, and then loop will be keep continuing. Moment we identify the right place at line number 12, you are seeing we are comparing with the card. The J will be having the card which is actually smaller than the one which is on my right hand. Either J will be having the index before the leftmost side, or J will be having the index of the place where the card is actually smaller than the card on the right. So it means I have to insert this card in a position next to J. If J is before the sequence, I should put the card on the first of the sequence. If J is at number 2, like second card is the one which is smaller than the card on my right, I have to put the card on the position 3, right? That's why I'm inserting the card on the right at the position J plus 1. When we are inserting the card right on the J plus 1, the card which is already there should have been already moved to the right? So when this card is going right, that card also should have gone into the next place already. So those things we are taking care in the while loop itself. So as long as the card on my right hand is less than the card which I am comparing, is smaller, that card which I compared is shifted one position right. That's why at the line number 9, you can see the card at left hand J goes to J plus 1. So now J and J plus 1 are having same values, but the position J is actually kind of empty. We can reuse that. So because it is already moved to J plus 1, I'm going to insert in J means it is not going to affect me anything. So in the while loop, I'm shifting each card. So in the while loop, I'm shifting one card at a time to the right, and moment I find the right card, I have a free spot also. I'm inserting the card on the free spot right away there. If you don't understand still, like if you are still a little bit confused, okay, so let me put this in a program and then we will do step-by-step debugging. Maybe doing a step-by-step debugging in parallel, checking the actual variables will help you better. Let's do that here right away. So here you can see the same code which we have seen in the presentation. So this is the insertion sort procedure, the function, and at the end of the program, like this is the start of the program in Python, I'm initializing this input with the same number which we have seen in the example 524613, and then I'm calling the insertion sort function with the input, so then printing the output whatever is being returned by the insertion sort. So I put a breakpoint here. Let me start debugger right away. Okay, we reached the breakpoint and we are currently in this print statement. Let's go into the function and see how the input is being processed inside the function. Jump into the function. Okay, so now we have a local variable on the left side you can see, which is the input sequence, which is nothing but A. I made the line number 2 is yet to run. Once we cross the run, we have one more variable left hand, which is having 6 positions, empty positions. We don't have any numbers right now. Okay, those zeros are placeholders. Now we are going to traverse the input list A, and then we are going to take one number at a time from A and then insert that on the left hand. Okay, so taking that, now I value is 0, it means 0th index. So the first number I'm taking from the deck, the first card or the first number in the sequence is 5. So that is assigned into the variable right hand, you can see here. Now right hand is 5. J is I minus 1, I is 0, so J is minus 1. And this while loop will run only when J is greater than or equal to 0. So this time J is minus 1, so this while loop is not going to run. So as we can see, the left hand is already empty, so I can directly insert in the first position. The right and the variable 5 can be inserted at the very first position of left hand. That's why it is not going into the while loop. You can see the very first position of left hand is position number 0. So that I am calculating by J plus 1. J value is minus 1. J plus 1 is 0. So left hand of 0 is right hand. Left hand of 0 will be number 5. So after this line's execution, you can see number 5 is inserted into the very first position of left hand sequence. Now we are going to take the second number and do the same. We have to do the insertion. So now I value is the second index. Second index is nothing but number 1. You can see on the left side I is 1. Then go forward. So the right hand value, the card right now I picked is card number 2. So this one has to be compared with the first card, index 0 in the left hand. So the comparison should start from the rightmost in the left hand sequence. So here the left hand sequence has only one value. One value means its index is 0. So I got to start my comparison from index 0. That's why I need the value J should be 0 at the start of the while loop. When I go into the while loop, you can see J value is 0. Okay, so always it is going to be 1 less than I value, because when I pick the nth card from the deck on the right side, in my left hand I already have n minus 1 cards. It means I have to start my comparison from the position n minus 1, right? So that's why my position where I have to start will be always I minus 1. So now J is greater than or equal to 0. J is 0, so this condition is true. And second condition is right hand should be less than left hand of J. So right hand is nothing but it is 2, and left hand of J, which is 0, that number value is 5, it is less than, right? So this condition also true. So we are going inside the while loop. So first thing is, as moment the number is bigger than the one which you are going to insert, we have to shift the number to one position right. So the shifting has happened. Shifting means I'm just not removing the first index, I'm just copying the value 0 from, value from index 0 to index 1. So the value at index 0 is just a stale value. We are going to replace it in a moment. Now what I have to do is, moment I compare with the rightmost card, I should continue my comparison to the subsequent cards, like one card before that, one card before that, right? So I have to compare the card on my right hand with the one card before the rightmost card. So that is J minus 1. If J is 0, J minus 1 is minus 1. So in this time, this condition is false. J is not anymore greater than or equal to 0. We are coming back here. It means we identified the place where you have to insert. Where you have to insert, which is J plus 1. J plus 1 is 0. So it means on this next iteration, like next, after the insertion got completed, line number 12, you can see the left hand input sequence is 2 and 5. Okay, so position 0 is inserted with number 2. Now going into the third iteration, I'm going to take the third number from the deck, from the input list. which is nothing but 4. So the comparison starting from the rightmost side of the input left hand sequence. So rightmost side is number 5. I have to compare number 4 with number 5. For that I need the position of number 5, which is nothing but 1 in the index in the array. So j value is 1. So comparing that, right hand, which is nothing but 4, 4 is less than 5. So the while loop is true. As I told you before, moment you identify there is a bigger number than the one you are going to insert, shift that number right away. Okay. So number 5 is moved into the position, the third position. So second position, number 5 is still there. It is tail number, which we will replace in a moment. Now I have to compare number 4 with the previous number in the sequence. The previous number is 2. So even though this condition is true, last time this j less than or equal to 0 condition was false because we have reached the end of the input sequence. But this time we didn't reach the end of sequence. This condition is still true because j is 0. But the second condition is false. So the number on my hand, on the right hand, is number 4, which is greater than the number I am going to compare. So left hand of 0 is 2. So 4 is greater than 2. It means I have identified the location where I have to insert the number 4, which is not the beginning of the input sequence. So the number 4 should be kept in between 2 and 5. So 5 is already shifted to the right. So I have a free place at position number index number 1. So the for loop, the while loop is broken. Now the insertion is going to happen. The right hand is going to be inserted at 0 plus 1. So after this line you can see 4 is squeezed in between 2 and 5. The similar way we have done on the card example. Okay. So take the third iteration. Right hand we have number 6. So we have to compare that with number 5, which is a position index number is 2. So j is 2. This condition is going to be false because right hand is greater than the number we are comparing. So it is not even going into the while loop, directly coming here. Now the j value is 2, j plus 1 is 3. So position 3, which is the fourth position, is placed for 6. So after this line, you can see 6 is inserted at the rightmost in the sequence. On the next iteration, we are inserting number 1. So comparison starting from the rightmost, which is nothing but 6. So comparison starts, comparison is true, 1 is less than 6. So when we identified 6 is greater than 1, shift 6 into the right side. 6 is shifted. Now keep comparing that. Now compare that with 5. 5 is greater than, shift 5 to the right. You can see 5 is shifted here. Now this is the empty slot. Again compare with 4. 4 is again greater than, shift 4. Now 4 is shifted to it right, and this is empty slot here. Then compare 2. Again 2 is also greater. Shift. Now shift 2 also. So 2 is also shifted. All the sequence in the left hand side is shifted one position to the right. Now we have the empty slot at position 0. This time we have already reached the end of the sequence. We have reached the left end of the sequence of the left hand side. So we shouldn't do any more comparison. The while loop should break. How the while loop is breaking? The j value is -1, which is less than number 0. The while loop will run only when the condition is true, but the condition is false now. We come out of the while loop. This time we are going to insert at the position number 0. J value is already -1. -1 plus 1 is 0. So after this assignment, 1 is inserted at the leftmost position of this input sequence. Similarly, continue for the last number in the input sequence, which is nothing but 3. Keep comparing. Start the comparison from number 6. 6 is greater. Shift it. 6 is shifted. Compare with 5. 5 is greater. Shift 5. 5 is shifted. Compare that with 4. 4 is greater. Shift 4. 4 is greater. Compare that with 2. 2 is smaller. So break the while loop and put it at the position where 4 was previously there, which is nothing but position number 3. Assign. The input sequence is complete now. 1, 2, 3, 4, 5, 6. Now this for loop should end. So we have told the for loop. This for loop will run once for each element in the input list, and we have already iterated all the elements in the input list. So the for loop will naturally stop here. Yeah, we have reached the end of the for loop. We came out of the for loop, we went to the end of this procedure. So we are returning the sequence which is stored in the variable left hand. So it is going to the print function, and print function printed it here. You can see here. The output is sorted permutation of the given input sequence. This is how insertion sort functions. If my explanation in the previous slide was not that much very understandable, you might have understood better in the debugging session. So we have seen the debugger, we have seen how the variables are keep changing. When you learn a program, you try this method. You start a debugger and then keep checking the variables. On every iteration, how the variables are changing, how the calculation actually happens. Moreover, the better idea is, the better method than this is, if you do the same debugging in a notepad, you take a notepad, you write the code on left hand side, on the right side you split that into variables and what is the current place the current instruction is running. You do a dry run on your own. You take some input sequence and run one instruction at a time, and after completing each instruction you come and update all the variables on the right hand side of the notepad. You may think it is time consuming. Actually it is time consuming only for the first time learning, but when you keep doing this, in the long run you will learn algorithms faster, you will remember them faster, and you won't make small silly mistakes like should you use less than or equal to, should you increment it before or after. These kind of confusions you won't get. When you do a dry run on a paper, those kind of small details will stick in your brain. So that thing you don't need to keep remembering, that thing you don't need to forget and then keep debugging. So initially, even though it looks like it is going to take more time, but your overall study of algorithms will improve better. So the time you are going to spend with learning algorithm will come down, right? So that is the best way I will recommend. Notepad, if you are little bit related to do in Notepad, do that in a debugger at least. Okay. So when you study an algorithm, when you learn a code, when you see that in a book or in a video like this, you may think you understood. You may think you got the concept. And then immediately you'll go and try to solve a problem. Immediately open a lead code which has a relevant algorithm, you'll try to solve a problem. There you will stuck. It will not work out immediately. Then you'll start debugging the code. Right. Here the problem is you understood the code. I'm not saying you didn't understand the algorithm, but there is a plenty of chances you have missed some details, some minor details like should the iteration should go to number 0 or -1, should the iteration go to the end of the rightmost sequence or one number below the rightmost sequence. These kind of small details we will tend to miss. We humans, we will not go to the machine level granular details, so that we tend to miss. We would have missed over there, and machines are not like us. They want each and every detail to be very precisely told. Okay, or at least until AI becomes something reality, machine should be told to a very basic fundamental details. So those kind of things, those kind of mistakes you can avoid if you do the paper based dry run or debugging. Hope this class was interesting and enjoyable. Hope you liked the class. Hope you learned something out of the class. Please take your time and comment here what I can improve in this video, or am I going very fast, or am I going very slow? Am I over explaining something which is very simple, fundamental, or am I not explaining something which is crucial, which is not sufficient here? So try to give this kind of feedbacks where I can improve the video, where it will be like less time consuming for you also. So you don't need to go through unnecessary explanations, right? And you don't need to go somewhere else also to search. You tell me where I'm missing, I will try to correct that. I will improve that in subsequent videos. Also, when you practice it, if you get any doubts or your code is not working, which you cannot able to debug on your own, I'm not telling immediately come and ask me the question, immediately put it in a comment. I'm telling you spend some time, at least 2 to 4 hours you have to spend while debugging, because initially learning, the amount of grind you are going to do is going to stay with you forever. So that is very critical here. Okay, so you spend at least some time, 2 to 4 hours. I'm not asking you to go and search in Google to get the right answer. You debug your code. You take minimum 2 hours, sit with your code, take each line at a time, one line at a time, and then do the dry run. or put it in a debugger and see how the variables are changing and how it is. One thing I want to tell you here is when you are debugging a code, you have to remember the code should be working like the algorithm. The algorithm shouldn't change for the code. Okay, you have written some code. Now you have to verify whether the code is it replicating the algorithm. So just because you have written something, you shouldn't change something else. Like you will change another variable, introduce new variable, and the code whatever you are writing will be completely deviating from the actual algorithm. This will tend to happen. So you don't worry about, you shouldn't be bothered about deleting the code. If you see something is not directly matching with the algorithm, delete it, remove the line, remove the for loop, remove the while loop, and rewrite it completely. Okay, so in that way you will save more time. Actually this will save more time. So spend 1 or 2 hours like that. Try to debug your own code, try to understand how the variables are changing, how the numbers are moving, and then if you still couldn't be able to figure it out, come and ask in the comment. Copy your code. It can be any language. I have experience with multiple languages, so you just put that here. I will try to answer you. Even if I couldn't able to answer, hopefully some other viewers who is seeing your code will come and help you definitely. Thank you. I hope you enjoyed the video. We'll see you in the next video soon. Thank you for watching.